About ballistics, what do they use that for? When you hear the word ballistics, where is that used?
Yeah, I think I'm a ballistic.
Crime scenes, yes. Okay, they use it to analyze if that was the same gun that was used. Okay, if the gun that was fired, was it fired at close range or was it fired from far away? If somebody claims that it was in self-defense, then there should be no burn marks on the shirt itself. But if they find that there are burn marks near the shirt, then probably the gun was fired close to the victim, something like that, right? Okay, so let's look at this example first. Dennis, can you please read?
The ballistic pendulum is a device used to measure the speed of a projectile, such as a bullet. The projectile of mass m is fired into a large block of wood or other material of mass m1, which is suspended like a pendulum. As a result of the collision, the pendulum projectile system swings up to a maximum height h. Figure 17-7-17. Determine the relationship between the initial speed of the projectile v1 and the height h.
Okay, so we're trying to find out the relationship between V and H. Now, you understand what it's trying to say, right? So this is what happens. You've got a block of wood, which we don't know. The mass is just M. We don't know what's the mass. And they fire a bullet. Okay. Now, what happens to the bullet as it hits the block of wood? It keeps going. Does it pass through the wood? It gets stuck inside the block of wood, right? So you could see there at the bottom picture. Yes? Okay. And then, obviously, what's going to happen when it gets embedded there? The wood starts to move, right? With the bullet inside. And what happens to the block of wood? Since it's tied, it goes up to a certain height. Yes? Okay. I have a question though. Is this an elastic collision or inelastic collision? Why inelastic? Does it say it's inelastic? They got stuck together, right? The bullet gets stuck in the wood. So remember what I told you yesterday? Anything in any collision wherein the first object gets stuck, it doesn't have to necessarily mean it's side by side. It could be embedded inside. So it's going to be a what? Inelastic collision, right? All right. Now, we're trying to determine the value of V in relation to this height. Okay. So we have small m, and it has a velocity of v going in this direction, right? Okay, so this is before it gets stuck. Now I'll draw. Now, what's the velocity of the big block here? Zero, right? And now let's just say the bullet gets embedded there. What do you think will now happen to this block of wood? It will not, same velocity? It will start to move forward, right? Well, initially to the right, but since it's tied, it will go up. Yeah? Okay. So here its velocity is 0. So therefore, what is its kinetic energy? The block of wood. It's 0. Now, when it gets embedded here, what's going to happen? It starts to move. Will it now have a kinetic energy?
Yes.
Yes, it will have a kinetic energy. Now, what will happen to that kinetic energy? This one will start to move up like this, just like what you see in the drawing. What happens to all that energy now? Huh? The kinetic energy increases? It goes faster? Okay, the kinetic energy is changed into potential energy. Yes?
Yes.
Yeah. Okay? So it's like me throwing a piece of ball going up. At the bottom is all kinetic, at the top it's all potential. So far, you're okay? Alright, so we will now try to determine what is the H. Okay? So therefore, let's try to determine the H. But how are we going to do it? Remember, the variables that we can use are M, big M, and V. Those are the only variables that we can use. No, we're looking for H. Okay? Well, you can look for H also. Let's say we'll isolate H. Okay? Alright, so we will now try to determine what is the velocity of this block of wood. So we'll start off with M1 V1 plus M2 V2 equals M1 V1 prime plus M2 V2 prime. Can we use M? So it's M. What's the velocity of the bullet? In this problem, what's the given velocity? What is it? Look. Come on. What is its velocity? V. Yeah, I wrote it here, V. Okay, does the second object, the block of wood, does it have any momentum?
No.
No, because it's not moving. So this one will be 0. Equals, now what can you say about their speed after the collision? It's the same, right? So you could say M plus big M equals V. I'll just use V prime. Yeah? Because they have the same speed. So we will end up with MV equals small m plus big M uppercase M V prime. Now, what is, if I isolate V prime, because I want to find its speed, initial speed, V prime here, as it starts to move forward, how would my V prime be isolated? Divide by? Okay, divide by M plus M. So that cancels, so V prime is MV over M plus big M. What is this V prime now? What is it? Is the velocity of what? Of what? Is it the same velocity as this one?
No, it's the velocity.
Whose velocity is this?
It's the velocity after collision.
Of the block of wood with the bullet inside it, right? So far, you're good? Okay. Now, using the law of conservation of energy, here it's all, what kind of energy? And here it's all? And what can you say about the kinetic and potential energy? They are equal, right? So kinetic energy here is equal to the gravitational potential energy here, right? Now, by chance, do you still remember, Andrew, what's the formula for kinetic energy? No? Mr. Hughes?
No.
No. Legacy.
Okay.
Kinetic energy, Andrea. mv squared. I'm so proud of you. mv squared over 2. What's the formula for potential energy, Courtney? Yeah, gravitational potential energy. mgh. Awesome. Isn't it? That's the formula? Okay. Now, at this point in time, what is the mass here?
Big M.
I'm sorry?
Big M.
It's just that big M? Okay, small m plus big M, right? That's the mass, right? Yeah? What is its velocity at this point? What is the velocity here? No. After it was struck, at the moment it was struck by the bullet and it started moving, what is its velocity?
That, right there.
Here, right?
Yeah.
And what is V prime equal to? M V. Oh, sorry. I'll just write the 1/2 because it's 1/2 mv squared, right? mv over m plus big M squared. Okay, slowing down a bit, okay? 1/2, or the 2 here, instead of m, because since the block of wood has the bullet in it, so it's m, lowercase m plus big M, right? And what is its velocity? We said it's mv divided by m plus uppercase M, right? And then there's a square, so it's squared. So far, are we good? Yeah, okay? Now, what is the mass now up here? What's the mass? Isn't it? It's going to be lowercase m plus uppercase M, right? And then it would just be G and H. Yes? Okay. Practically, we're just solving it algebraically here. No numbers. Okay. So, if I combine this one now, it will become M plus uppercase M times mv squared over 2m plus big M squared. Yes? Okay, equals m plus big M g h. Now, can I simplify the left side of the equation? Okay, lowercase m, and what will happen here? The square here, right? Okay, so now you will have mv quantity squared 2m plus uppercase M. Yes? M plus big M G H. Okay? Now, it all depends. If what do you want to isolate? Do you want to isolate V or do you want to isolate H? Because it says, determine the relationship between the initial velocity of the projectile V and the height. If you want to find the height, then we'll isolate height. If you want to isolate V, then we can isolate V. Let's isolate the height. So if you want, what will we do to isolate the height? Divide by M plus big M. Yeah? And by G, right? Isn't it? So what will we do to this side here? Divide by M plus big M over G. And what's going to happen? That cancels and the G cancel out. H now would be equal to mv squared over 2g m plus m squared. That's how it will look like if you're trying to isolate H. Okay? But try to go beyond the math here. Just try to remember that all the kinetic energy here is changed into what? Potential energy. And since the kinetic energy is not conserved, then it's going to be an inelastic collision. Okay? Okay, very good. I'm so proud of you. So we're isolating H in this case. If I want to find out what's the V, if I give you the H, then you can just simply solve for H, or for V rather. Okay, last one. My 4th period class earlier this morning, we finished this. I hope we can finish this. All right, collision in 2 or 3 dimensions, and this is what they use in fireworks. How do they make those fireworks have those different shapes? It has to do with collisions in 2 or 3 dimensions. All right? Okay. Now, what does it say, by the way? Trying to simplify it. So in collisions, for collisions in 2 or 3 dimensions, the sum of the momenta What's momentum, by the way? Plural of momentum. In the x and y axis should be equal before and after the collision. So meaning if you add up all the momentum of the x, it should also equal to all the momentum of the x-axis after the collision. Before we go to the math, okay? Let's go back to that example of the warm-up. You have a ball going there with an initial velocity of 5 meters per second. And you have M1 and M2. So this one is going to the right. Does it have momentum? Does this one have momentum? Yes, because it's moving. How about this one? None. Okay. Now if I were to examine this, if we use the Cartesian coordinate system wherein this is x, that's y. This velocity is going to the right, so it's going to be x, all x, right? Now, does it have a y velocity in the first place? None, right? Because it's just rolling to the right like this. So it has no velocity on the y. So guess what? What is its momentum on the y-axis? 0. Okay? If it's going to the right like this or going to the left, what is its y momentum? 0. If there is a ball going up and down, like this, it's just plainly going up and down, what is its x momentum? None. You get it? Very easy, right? Because it has no velocity on the x-axis, so therefore its momentum on the x is 0. Okay. Let's try to apply this. That's why if you notice, it's momentum on the x plus momentum on the second object on the x is just the same, right? Like what I did before. So if I were to list this one down, it would look something like this. M1 V1 sub x plus M2 V2 sub x is equal to M1 V1 prime x. That's for the x-axis. Now, how about for the y-axis? It's just going to be the same. M1 V1 y, plus M2 V2 y should be equal to M1 V1 y prime, M2 V2 prime y. Yes? Okay, let's apply this. Okay, Kaylin, can you please read?
Sure. A billiard ball moving with a speed of v1 equals 3 meters per second in the positive x direction strikes an equal mass ball initially at rest. The two balls are observed to move off at 45 degrees. Ball 1 moves above the x-axis and ball 2 below. What are the speeds of the two balls?
Okay, thank you very much. So you have a ball that's moving to the right. Let's say this is M1. What is its velocity, by the way? 3 meters per second. Yes? Now it hits another ball that was at rest, isn't it? Okay? What is the velocity of V2? 0. Okay. Before they collided, does it have any momentum on the y-axis? Huh? None. Why? It was not going up and down. Its velocity was just going straight to the right, so it's all x momentum, right? So far, did you understand that? Okay. Now, this is critical. This is before they collided. After they collided, what happened to the blue ball? Where did the blue ball go? Where did the blue ball go? To the right? Oh,
After it collided?
after it collided, where did the blue ball go? It went back? No, read the problem.
It went to the positive.
Huh?
Oh,
45 degrees, right? So therefore, after they collided, let's say the first ball, let's just say that's my M1, the first ball went up this way.
45 degrees.
Yeah, 45 degrees. So this is 45 degrees here. Okay. And do we know its velocity? Do we know its velocity here? Did it say it stopped? No, so it's just going to be V1 prime, right? Now what happened to the second ball, or in this drawing the red ball? Where did it go? After it collided, it went down this way. Does it not say that? Okay, the two balls are observed to move off at 45 degrees. Ball 1 moves above the x-axis and ball 2 below. So it just went down here. So what is this angle again here? 45 degrees. Do we know its speed? So we'll just say V2 prime, right? So far, are we good?
Yes.
Okay. Now, as what Nick had said, by the way, since it's moving to the right, what's the momentum on the y-axis? 0, right? So what should be the momentum on the y-axis after collision? 0. You understand so far? Because it's just moving to the right. It's neither moving up and down. So if momentum before the collision on the y is 0, therefore the momentum on the y after collision should also be 0, right? Okay. Now this is where...
Is that all the time, or does that have to do with the inelastic collisions, right?
It doesn't matter whether it's elastic or inelastic. Okay. Good question, though. Good point of clarification. This applies to both elastic and inelastic collisions. Okay. Now, this is where it becomes, interesting. Okay. Since it's going at this angle, we have to look for its y and x components, right? So where is its x component in this case? It would be this one here, right? Right? So this is now our V2 prime x. And this one would be our V2 prime y. Yes. I like the smile in your face, Mr. Yu. And of course, if this one has an x and y component, do you think this one has an x and y component?
Yeah.
Of course. Life would be so boring without the x and the y components. So therefore, this one would be V sub 1 prime x. Yep. And this one would be my V sub 1 prime y.
So we're going to try to solve for the hypotenuse?
Yes and no. We're not going to. We'll solve for the hypotenuse later. Okay. In relation to this angle, relative to this angle, the x component, is this one your adjacent or is it your opposite?
Adjacent.
Adjacent, right? What function uses adjacent and the hypotenuse? Is it sine or cosine? I'm sorry? Cosine. So this one is cosine negative or positive 45? Negative 45 degrees. And what is the hypotenuse in this case? V2 prime, right? Okay. Now, in relation to this, relative to this angle, these are equal. Do I use the sine or the cosine for this? Sine, right? So this one would be sine negative 45 degrees. And my hypotenuse is V2 prime. Okay? I'll give you time to digest.
That's nice.
Only that one's negative, right?
Yeah, only this one here, because this one is going to be positive.
Okay.
Okay? Alright. We're still okay? No magic yet, right? Okay. Now in the same manner, if this is relative to this angle, you would call this side as your adjacent, right? So just like what we did with adjacent, it's going to be cosine 45 degrees times V1 prime, isn't it? And this one would be equal to my sine 45 degrees V1 prime. Yes? Okay. So we've just broken it down, and then we're at this point now here. Okay. Let's solve for this part here. Momentum on the x-axis. Okay? M1. How much is V1? 3, right? Times 3. And what's the momentum of the second, what's the mass of the second object? We don't know. But by the way, their masses are the same, so it doesn't matter what m we're using. What is the velocity of the second object before they collided? 0. We're looking at the x, right? Okay, so m1 is just m. What is its x component after the collision? What's the x component of this after collision? Isn't it? It's cosine 45 degrees times V1 prime. Yeah, this one here. Yeah? Yes? Okay. Plus, again, I'm looking at this one now. M. And then it's going to be this one here, right? Cosine be careful, negative 45 degrees times V2 prime, isn't it? Okay. Now, if you notice, they all have m's. And since we're looking for the V prime, we can cancel out all the m's. So it will just be 3 is equal to cosine 45 degrees times V1 prime plus cosine negative 45 degrees V2 prime. How many unknowns do we have here? 2 unknowns, so we can't solve it yet. But don't worry, we'll get there eventually. Okay, can somebody get their calculators, please? Can you give me cosine 45? 0.07 V1 prime. Okay, cosine negative 45 degrees. Make sure you plug in negative 45 degrees. It still stays the same. So it's going to be 0.707 V2 prime. No, you can't do that because they're not like terms.
But it's a different.
It's a V1 prime and it's a V2 prime.
It goes below.
It's a different velocity.
Okay. Now, how will we solve this one when there are 2 unknowns? Then we'll set it aside first. Set it aside.
Can you use that one?
Okay. Now we're going to use the y-axis, but we already know, don't worry. What is the momentum of the objects on the y-axis before they collided? 0, right? Okay. I'm supposed to write it somewhere. Can I just write it down here? Here?
Whatever you want.
I'm sorry, okay? And you already know that before the collision, it's equal to 0 here, right? So I will just write here 0 for this. Equals M1 what is the y component of the first object before they after they collided? No, the y velocity.
Oh,
It was sine
45.
sine 45 degrees v1 prime, right? Now, what is the velocity of the second object on the y-axis? This one here. Sine negative 45 degrees v2 prime. Yes? Now again, since can we divide all of this by m? Yeah? And if you divide that by m, what's going to happen is I'm still going to get 0 here. Sine 45 degrees v1 prime plus sine negative 45 degrees v2 prime. Yes? Okay. Can somebody get a calculator and get sine 45? 0.707 v1 prime. What about sine negative 45? Okay, negative 0.707 v2 prime. Negative, be careful with that, that's a negative. Equals 0. Okay, I'm sure you know more or less where are we heading at, right?
You're just gonna isolate, right?
Yeah, I'm going to move negative 7.07 to the other side. If it's negative, what will happen to its sign if I bring it to the other side? It will just be positive 0.07 v2 prime equals 0.707 v1 prime, isn't it? Yeah? And then I'll try to isolate one of them. I'll just isolate v2 prime. Yes?
Are they both equal because your angles are exactly the same?
Well, yeah, it just so happened that they're equal because the angles are the same. But do they have to be the same all the time? No. Okay, so if I divide this by 0.07 by 0.07, what equation am I going to get? V2 prime is equal to V1 prime. Now again, will they always be the same? No, it all depends on the angle. When the angles change, then obviously they won't be equal to each other. But what's important is you try to isolate one of the primes on the y-axis. Okay, now let's bring this one back to this one here. What is V2 prime equal to?
V1 prime.
V1 prime. So therefore, instead of writing V2 prime, I can just now continue. I'll just continue now 3.707 V1 prime plus 0.707. Instead of V2 prime, what will I write? V1 prime, right? Now, how many unknowns do I have? One. No, one. V1 prime. Yeah? Now, what will we do? Well, almost there. What? Two more steps. What's the last step now? Is to collect like terms. And if you add this one, you're going to get 1.42. I'm sorry?
You get 1.41.
1.41, right?
Yeah.
V1 prime equals 3. And what's the last step?
2.12.
Divide by 1.41. Divide this by 1.41. V1 prime now is equal to 2.1 meters per second. Okay? And what is V2 prime equal to? It's also, since it's the same, then you're going to have the same speed. Okay, if the lesson was kind of confusing, just log on to PBTV and it will be there.